Welcome to aminacademy.com. In mathematical economics, let us discuss about some solving problem by using derivatives. Look at this example. Test whether the following functions are increasing or decreasing at x equal to 5. Look at here. First function is given as y equal 3x squared minus 14x plus 8. Now we have to find first derivative, that is y dash equal 3x square derivative is 6x, 14x is derivative is 14. Now substitute y dash at x equal to 5. 6 into 5 minus 14. 6 into 5 is 30 minus 14 is minus 16 minus 16, which is lesser than 0. So the function is decreasing. The function is decreasing at x equal to 5. Next question, y equal x power 4 minus 6x cube plus 4x squared plus 8x. Here y is first derivative with respect to x is 4x, x power 4 derivative is 4x cube minus 3 into 6 is 18x squared plus 8x plus 8. Now we have to substitute y dash at 4. Y dash at 5, not 4, equal 4 into 5 cube minus 18 into 5 square plus 8 into 5 plus 8. So we have 125 into 4 is 500. 18 into 25 44 90 and 36 0 450 minus 450 plus 40 plus 8, so which is equal 500 548 positives 548 minus 450 which is equal 98, which is a positive, so greater than 0. So function is increasing. Function is increasing. Next question. Test the following function is concave or convex at x equal to 5. Here the function is y equal 5x squared minus 8 whole square. Then y dash equal 2 into 5x squared minus 8 power 1 into 5x squared derivative is 10x and derivative of 8 is 0. So we have 20x 5x squared minus 8. So which is equal so then 20x, that is 100 x cube minus 160 x, then we can find for concavity, we have to find y 2 days. Y 2 days is 30, then y 2 days is y 2 days, how to find this is 3 into 100 is 3 is 30x minus 160. 100x cube. Your y 2 days is 3 into 10 is 30 x square minus 160. Here this 100, not 20, is 100. Then this is 300 because 20 into 5 is 100. So y 2 days equal to 300 x squared minus 160 at y 2 days at x equal to 5. 300 into 5 is 25, 5 squared is 25 minus 160. So it is, of course, it is positive. So it's positive, so convex. So it is the second derivative gives the value is positive number, so it is a convex. So this function is convex at x equal to 5. Next, find the relative extrema. Find the relative extrema of the following function: minus 7x squared plus 126x minus 23. How to find the relative extrema for so we'll change the function here. This relative extrema for f of x equals, suppose, minus 3x cube minus 36x square plus 135x minus 13. No, this question is given here. We have to find relative extrema of the following functions. Look at here. For the following function, critical values, test for concavity to determine relative maxima or minima, check for the inflection points and evaluate the function at the critical values and inflection points. 4 things we have to find. The function is given. First we have to find critical value. For that, look at here. This function is given as 3x cube minus 36x square plus 135x minus 30. This first we have to find first derivative of this function. 3x cube derivative is 9x square and 36x square is minus 72x because 2 into 36 plus 136, 135x derivative is 135. So you have to equate 0. So first of all equate 0, then Take 9 as a common factor of this. So x square 8x, because 8 9s are 72, then plus 15. 15 into 9 is 135. Then we have to factorize x square 8x plus 5. So factorizing is 5 here 15. 15 is 5 into 3. 5 into 3. So both minus. Therefore, x minus 5 into x minus 3 equals 0. Since 9 equals 0, we remove this 9 and we are factorizing this quadratic, that is x squared minus 8x plus 5 equals 0. And these factors are x minus 5 and x minus 3. Therefore, x equal to 5 and x equal to 3. These are critical values. These are critical points or critical values. Now, we have to find critical values point. Second one, test for concavity to determine relative maximum or minimum. Next, for the second, f2 dash of x. You have to find f2 dash of x. F of x is this one. F dash of x is this. This derivative is 18x minus 72. So we have to put the critical values. First, f dash of f2 dash of 3. We got a critical value 3 and 5. First we substitute 3. 18 into 3 minus 72 is minus 18. This is lesser 0. Concave relative maximum. This is concave relative maximum at x equal to 3. Then next one, f2 days of 5. 18 into 5 minus 72 is equal positive 18, which is greater than 0. Therefore, it is convex. It is a convex relative minimum. This function have relative minimum at x equal to 5. So, next question, optimize the following function. Next, we are optimizing the, look at here, optimizing the following function. Y equal to x cube you have to optimize the functions. Look at here. Optimize the function y equal to x cube minus 6x squared minus 135x plus 4. Then we will continue this. Here first we will find, for optimize the function, you have to find first y dash. Y dash is 3x square minus 12x minus 135. Look at here, x cube derivative is 3x square minus 6x square derivative is minus 12x and 130 minus 135x derivative is minus 135. Y dash equating 0 to find the critical values. So take 3 is common, x squared minus 4x minus 45 into 3 is 135. 0. Therefore, we can say the quadratic function x squared minus 4x minus 45 equal to 0. This minus 45 can be written as the product of minus 9 and 5. Minus 9 and 5 are 45 and minus 9 plus 5 is minus 4. Therefore, factors are x plus 5 and x plus 5 and x minus 9. In that, this 3 also you can write it here, then which is equal 0. Look at here, here 3 equals 0, it's no value, that's x equal to minus 5 and x equal to 9. This is a critical values. Now from that critical values, we have to find, optimize the following function. For optimizing, we have to get y double dash. Y double dash is, look at here, y dash is this here. Therefore, 3x squared differentiation is 6x minus 12x is 12. Then put both values, critical values. First you substitute y dash of y double dash of minus 5, which is 6 into minus 5 minus 12, which gives minus 30 minus 42. Of course, it is lesser than 0. So concave relative maximum. So concave relative maximum, the maximum, and y equal y dash double 9, y double dash of 9 gives 6 into 9 minus 12, which is equal 42. Then which is greater than 0, this is convex and relative minimum. Relative minimum. For finding the optimize means we have to use this maximum, this values y equal to minus, therefore here x equal to minus 5, x equal to minus 5, we have to use an original equation, that is y equal to x cube, y equal to x cube minus 6x squared minus 135x minus 6x squared minus 135x and plus 4. For optimize, that is maximum optimize means is maximize the function, that is we have to use y of 5, that is y cube minus 6 into y square minus 135 into 5 plus 4, which is equal 125 minus 25 into 6 is 150 and 5 5s are 25, 2 carries, 5 3s are 15, 7, 5 ones are 5, 575, that is 5 5s are 15, 25, 2 carries, 5 3s are 15, 15 into 2 is 17, 1 carries, then plus 4, which is equal 125 plus 4 is positive value is 129. The negative value is 5. Negative value is 5 and 5 plus 7 is 12. 1 carries 7. So we have this. We have the answer is, we have the answer for this which is equal 15 minus 9. 15 minus 9 is 6, and 1 minus 2 is, so 1 here, 125, you can put it 725 minus 129, 6, 11 minus 2 is 9, 5, 9, 6. This is the maximum. Maximum value is at minus 596. So far we discussed about some solving problem regarding critical values, and maximum is the function, relative extrema and relative minima, like that. We have done. Please subscribe our YouTube channel.